So hello guys, this is my tutorial to find tweet trends. Basically take tweets from tweet streaming API, sentiment analyze those and display them on a Google Map API with the correct sentiment and the tweets regarding to the keyword. Basically this is where we're going to type the keyword, and when we hit find trends, so that would basically fire a first Lambda function which would fetch the tweet from tweet streaming API, send them to an SQS, simple queue service, and then SNS topic, which triggers a second Lambda. Second Lambda takes the tweet from SQS, sentiment analyzes those tweets, and sends them to another SNS. So this triggers a third Lambda function which takes the tweet with the sentiment and basically indexes them onto Elasticsearch. So basically this is where we're getting the tweets which are saved onto Elasticsearch, which are deleted for every time I hit a new keyword. So this is a negative sentiments icon. So this is basically the location and the person who's tweeting. So this is a neutral sentiment icon, and this is a positive sentiment icon. So as you can see, I'm getting tweets and the sentiment for the keyword Trump. Yeah, so let's move on to the code and what technologies I've used. I've used NodeJS for implementing the backend using AWS Lambda, and I have used two streaming APIs to basically fetch tweets, and then I'm using sentiment analysis API from IBM Watson, which is NLU API, which you can find the link from my GitHub repo. And then I'm using SQS to take the tweet from the stream, send off formatted properly, and then send to SQS, and then I use SNS to trigger another, my next two Lambdas, and then I use S3 to host the front end of the API of the tweet trends app, so where we can basically type the keywords and find the tweets. And this is the Elasticsearch. Basically this is a NoSQL kind of database and our search engine, which helps to store as well as get tweets as fast as possible. And then you use API Gateway to export the lambdas to my front end. And then I use Apex, which is basically a command line tool to test the APIs in local development and send them to your AWS cloud. So basically you have to set it up using these two commands. Then you have to just add your AWS credentials onto that, and then you're good to go. Basically then you have to create a project, add IAM roles, which I'm gonna discuss it in a minute, and then I think we're done. So this is basically the project structure. This is where the minimal configuration is defined, and this is how the structure how it looks. So basically in our project we have three Lambdas, which I'm going to show you in a short minute. And this is like the main file that gets fired when a given Lambda is triggered. And then we are going to have packet.json file here instead of this, and some known modules here to accompany our index.js. So let's get onto the code. Yeah, so as you can see here, I'll go over this basically the faster way. So this is like the checklist I created when I was developing the app. So this is going to be the first Lambda, which fetches tweets from the tweet streaming API, filters the location. If the tweet doesn't have any location, we're going to filter that. I'm just going to check for the language to be English, which is basically because the IBM Watson API is not capable of analyzing tweets which are not in English. So basically that's why we're going to filter these two key criterias, which I'm going to show you how I've done. And then after filtering those tweets, I'm sending them to SQS, SNS. Sorry, that's my phone. So I send to SNS, a second Lambda gets triggered. Second Lambda takes the tweet from SQS, sentiment analyzes using IBM Watson API, and sends them to a second SNS topic, which then triggers the third Lambda function. The third Lambda function takes the tweets from SNS topic and indexes them to ElasticSearch. Then the client listens to the ElasticSearch, where if we get new tweets, then those tweets are showed over here. See? So I'm going to show you the tweets that are indexed, like how many tweets that are indexed onto the Elasticsearch. As you can see, there are 10 tweets indexed, and there are about 10 tweets that were showed over here. The UI is created using material design, not much, just to make the top bar look a bit more receptive to audience. Okay. So let's move on to the NodeJS code. So this is how I showed you the directory would look like, which is looking like here. So basically this is our functions and a project.json file. And then these are the three functions. So the starting function would be tweet to SQS and SNS. This is the package.json file where I stored all the modules. So basically if you do npm install in this directory, all the node modules would be get installed. So this is how the code would look like. Not pretty, but it gets the job done. So the console log here are done just to know that you're getting the data, and you can see it in the CloudWatch. So first we are going to import the Twitter API, which has the streaming functionality in it, and the AWS SDK for getting SQS and SNS. Then ElasticSearch to send ElasticSearch to delete the index on every search. So basically when we type the search, all the old indexes and the data get deleted so that the new data can be searched. And this is basically the AWS configuration, so that our Lambdas have the access to basically send the tweets to SQS. So this is the SQS instance we're creating, and these are the Twitter API credentials, which you can get by going here to Twitter. You can create a project here, and you can basically you can input the credentials here, and you can get the tweets credentials from here, and you can put them in the environment variables. Environment variables are going to look something like this. So basically you type here consumer key, and the appropriate consumer key over here, so you would know that, so the Lambda can fetch the environment variable, the credentials from the environment variable. This is like a good practice to store key values into code directly. And this is like the host URL for Elasticsearch, which you're gonna get from over here. After creating a new domain, you can click here, copy the link, and go to the environment variables and create an environment variable name is host URL and slip that over there. Then this is the export handle, which basically gets fired when you trigger this Lambda from the front end. So basically you can see here I'm deleting all indexes which are on my Elasticsearch host. So after that I'm starting the Twitter streaming API for the keyword which I'm getting from the front end. So basically this is the event that was triggered, and from that event I'm getting the keyword, and I'm using that keyword to track for the Twitter stream. So whenever I start the stream, and seeing if the index is not defined, if the index has place and there is a full name in that place, and if user in event, that means if it's not a bot that creating the tweets and the language is English. So yeah, this is like the parameters that I've used for filtering out the details from the event. There are a lot of details that you get from when you get the tweet from Twitch.me API. This is the basic details that I'm gonna need, which are showed previously on the map. Basically, the string event, the ID string which relates to the user, his profile image, screen name, full name, and basically from which location the tweets are coming from, and the created and the text. And this is basically the queue URL which you get from over here. So whenever you create a new queue, you get a queue URL over here. Basically this thing over here. After that, you create we have created an SQS object just over here. So we send the message with these parameters to the queue, which we have the URL here, and what are the parameters and the extra parameters we're sending with the message ID. If the sending is successful, we are writing a callback function which outputs the parameter, and we're creating an SNS store where we're going to publish if the sending is successful. So we're going to get a topic on from the SNS topics, and then basically when the stream is successful and say we get an error in the stream, we just throw the error and stop the function. And we have timed this function for like 30 seconds or 1 minute. So basically after 30 seconds the function 10 minutes, and we get whatever tweets we get in 30 minutes are showed onto the are sent to the SNS topics. So we're gonna move the second Lambda function. So this is the sentiment analysis API. This is how you write it. You get the username password through over here when we sign in, and then we're creating a params to receive the tweets. So these are the two main important things, where visibility timeout is like whenever you fetch the tweet from the queue, you hide the tweet for 5 seconds so that so that another instance of this Lambda gets triggered. The same tweet is not fetched from that API. And then this is the wait time. So basically whenever the Lambda is triggered, it waits up till 5 seconds for the tweet to receive as SQS in asynchronous. So this is like a good practice to wait for 5 seconds, which I've said in my implementation. So basically we receive the message from SQS, you do some filtering over here, you take the tweet and the text, and then for this after that you delete the SQS, delete it from SQS, and do the sentiment analysis over here, and then we publish the tweet with the sentiment onto the second SNS. So now from SNS to ES. So this Lambda takes the tweet from SNS, as you can see over here, and whenever it takes the tweet from SNS, we get it through the event, and so as you can see over here, I'm taking the tweet and indexing onto my index tweet trends, which you can see over here. It's getting indexed every time. See, tweet trends index. So basically this is how the serverless implementation works. I'm gonna add architecture diagram for better understanding of this. I hope that you find this video helpful and give us a thumbs up. Okay, see you guys.